Finally, what has happened to the insects? More than 137 different species of insects have become resistant to some insecticides. This is the reason for producing new chemicals each year to which the insects are not resistant. Jay McMullen asked Dr. White-Stevens, why is it necessary to produce pesticides that are a potential hazard to people?
Well, of course, the problem is that we have to kill the insect. We do everything we possibly can to produce compounds which are toxic to insects, but not particularly toxic to animals. This is a very difficult thing to do because living processes are fairly common to all creatures.
Carson contends that pesticide chemicals are used without sufficient knowledge of their effects on man and his environment. Yet, according to industry, each new pesticide that reaches the market undergoes some 3 to 5 years of experimentation, costing as much as $2.5 million. Pilot field tests must prove the pesticide's utility to the Department of Agriculture. The Food and Drug Administration must review all experimental data on animal tests and certify that the pesticide can be used safely if label directions are followed. Despite all this, do we know enough about the effects of pesticides? McMullen questioned Dr. Paige Nicholson, water pollution expert, Public Health Service.
Do you know how long the pesticides persist in the water once they get into it?
Not entirely.
Do you know the extent to which our groundwater may be contaminated right now by pesticides?
We don't know that either, nor do we know if concentration may be occurring in groundwater.
Do you know the effect of long-term exposure of pesticides on aquatic life?
Not completely.
Do you know how pesticides may interreact within water organisms?
This, too, is an area where we need to know more.
What remains to be known about the effects of pesticides on birds and other wildlife? Dr. John Buckley, Director, United States Fish and Wildlife Research Center.
Proportionally, we've just barely made a dent in this whole field of knowledge. We've examined something like 60 compounds out of the several hundred that are in common use. We've examined their effects on not many more than a dozen species, and yet there are well over 1,000 species of birds alone, well, birds and mammals that we're concerned with. There are many kinds of fish that we're concerned with, and yet it's only a few of these that we've looked at all. In addition, we'd like to know the levels of residues of most of the common pesticides throughout the total environment. And we find them on birds, for example, taken from almost any place. And it's most unusual to find a fish sample from any place that doesn't contain a detectable residue. We need to know the rate at which these are taken up, the rate at which they're eliminated, the length of time that they stay, the part of the organism that they affect, whether they, for example, we find concentrations of certain of these in the brain tissue, in liver tissue, in the testes, in the breast muscle, just widely scattered through the animal, largely tied up in the fats of the animal wherever they may be.
Do you need to know then how these concentrations affect these particular organs, the brain, the liver?
Yes, we need to know the effects of these compounds on each of these organs, or conversely, the lack of effect. But we need to know we need to answer the question, so what, when we find this material here? What does it mean? And this I don't think we know well for any compound in any individual bird.
Finally,